let's go over the phase diagram. In previous SPM, you're gonna learn about the freezing point, melting point, condensation, vaporization, sublimation, and deposition. Deposition, which is you come to know the concept of freezing is the substance change from the liquid to solid, and melting, whereas the substance change back from the solid to the liquid, and condensation, the substance change from a gas to liquid, and vaporization. Sublimation is the substance change directly from solid to gas without going through the liquid phase, and deposition is the substance change directly from gas to a solid without going through the liquid phase. But in look at the phase diagram, it is a relationship between pressure and temperature, and a phase diagram is a phase when a substance will be in at particular temperature in certain pressure. When the look at here, this is a point of example of water. When the pressure dramatically lowered, we can see how water will sublimate to the gas vapor. So the line here, you see the line, there are three lines here. The line is representing the when the equilibrium between two pairs, you'll see line here is representing is in equilibrium. When the point is according to the point here in a line, it is in equilibrium between two pairs. And triple point, you see the triple point in whereas the equilibrium represent at the three phase, between three phase, among the three phase. And while the critical point is the point of substance which is the highest temperature and pressure at which a gas and liquid can coexist at equilibrium. So you have to memorize at the standard STP 101 at the point when it cross over the ice, goes to the water, and goes to the gas vapor pressure. The point is going according to the temperature increase. At 100% in 101 pressure, the line is in equilibrium between water and vapor. Move over the 100, it will go to the gas. Okay, next. So we look over the structure of the solid. Actually, solid is, we try to look from the macromolecule to the micro of the solid. So the solid is something which is new for you, and we identify the structure of the solid in order to know better about solid. So at this point, you have memorized certain terminology, specific terminology, which is crystal lattice, what is the crystal lattice point, unit cell, and so on. So crystal lattice is come of the definition for 3D array. You see here is a 3D array of points that represent an identical environment within the crystal. So crystal lattice is the regular geometric pattern of the unit making up the crystalline solid. This one is a crystalline solid which is made up from the 3D dimension. So the repeating unit, we'll call it crystal lattice. So the point at the edge of the crystal lattice is so-called lattice point. So one single unit of this is so-called unit cell. Lattice point can be either atom, molecule, or ion. Okay. There are three types, the general type of unit cell. First is simple cubic. The second one is face-centered cubic, and the last one is body-centered cubic. So you see here, at the edge of the unit cell is called atom. It is a lattice point, and you see, okay, this one is you can see the range of all the lattice point. And okay, you see here in a simple cubic cell, it is made up from the 8 atom. Not 8 atom, but it is a 1/8. For at the end of the edge is actually this one is 1/8 times 8, because of the atom of the edge is 8. 1, 2, 3, 4, 5, 6, 7, 8, which is 4 at the top and 4 at the bottom. For the body-centered cubic, this one, they have a 4 at the top, 4 at the bottom, and add on the 1 atom in the middle of the cubic. So this atom is considered 1 atom plus 1/8 times 8 at the edge of the unit cell, make it 2 atoms. For the face-centered cubic, actually is a face means side by side of the cubic cell is made up from the face-centered, meaning to say that they have 1/8 times 8 at the edge, 4 at the top as in previous, plus to the 1, 2, 3, 4, 5, 6, meaning to say they have a 6 half atom, make it 3. So in total 3 plus 1 equal to 4 atom. So in general, simple cubic cell is 1, body-centered is 2, and face-centered is 4. You don't be confusing, and it is okay if you're confused in this part. You need to figure and try to imagine how the atom can be occur at the certain place, and you can see better when you look at the video that attached from the Padlet. Okay, in summarize, in a body-centered cubic cell, there are 8 corners atom and 1 centered atom. This is body-centered cubic, and then therefore they have 2 atoms. Face-centered is 8 corners atom and 6 surface atom, make it 4. This one is a hexagonal. Actually, it is extra. For simple cubic is 1 atom. So they have a 7 basic unit cell that you have to memorize. They have a different pattern and different structure, but it is a basic unit cell. They have certain exist in a cubic, certain exist in tetragonal, orthorhombic, rhombohedral, hexagonal, monoclinic, and triclinic. So that's the character of solid that exists in the world.